The next thing I want us to find is the complement of E1 union E3. So E1 is still the sum of numbers is greater than 9, and E3 is the numbers on the two dice are equal. So I know what E1 union E3 looks like, and I want to find the complement. Remember, the complement of an event is everything that's not in this event. So I could find my set, this set up here, by crossing out all the elements in E1 union E3, and then everything remaining, all these should have parentheses, guys. Sorry about that. Everything remaining is in my set. So let's try this again. So 1, 1 is in my set, so it'll be in my won't be in my complement. 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, and then all the points here, 6, 4, 4, 6, 6, 5, and 6, 6. So E1 union E3 complement is all the elements I have not crossed out. And I'm not going to rewrite that set because it would take a very long time. This is our new set. Get rid of the orange. Let E and F be events in a sample space S. Events are mutually exclusive. These are also called disjoint or independent when E and F cannot occur at the same time. Okay? That means if E occurs, F does not, and if F occurs, E does not. And their intersection is going to be 0, right? Here we have them represented with a beautiful Venn diagram like we did in chapter 5. And we see that these events do not overlap. A good example of this would be flipping a coin. You get heads or you get tails. That's it. You don't get heads or tails at the same time. It's also important to note that you could have a multitude of independent events. If we were rolling a dice, you could get a 1, a 2, a 3, a 4, a 5, or a 6. These events do not overlap, right? These events are mutually exclusive. The same thing could be true if I was rolling a dice and I wanted to get evens or odds. Even numbers, odd numbers. So, for the experiment of rolling 2 dice, which of the following are mutually exclusive? The sum of the dots is greater than 9, the sum of the dots is 7 or 11, and the dots on the 2 dice are equal. These are the 3 groups we had. So let's take a look. There's E1, E2, and E3. There should be parentheses around all of this. I don't know what's happening today. Okay, so let's look at the possible intersections of these sets to make sure, to figure out which, if any of them are mutually exclusive. So I need to look at E1, E2, E2, E3, and E1, E3. So let's look at E1, E3. E1, E3 is going to overlap with E2 at the points 5, 6, and 6, 5. So this is going to be their intersection. Therefore, they are not mutually exclusive. And friendly reminder, I just tried to fix it, but all these should have parentheses around them, right? Because they're each representing 2 dice rolls. Okay, so let's look at E2 intersect E3. E2 intersect E3. Do you see anything in common? I sure don't, right? So their intersection is the empty set. So these 2 events are mutually exclusive. Last but not least, let's take a look at E1 intersect E3. We can see that these events overlap at 6, 6, and 5, 5. So again, these 2 sets, these 2 events are not mutually exclusive. Just like I said, but again, missing all of my symbols. But they are on the PowerPoint, so feel free to double check that for clarification or send me a message. So let's talk about something where the event space is a little less defined. Well, it's very defined, but we don't have the entire set listed out. So for example, let's let S be all positive integers, right? Remember the integers are 1, 2, 3, 4. These are positive integers. Let's let E1 be all even numbers. So that's 2, 4, 6, 8. Any number that's a multiple of 2 is an even number. And let's let E2 be odd numbers. And E3 is all prime numbers. You guys remember what a prime number is? A prime number is any number that's only divisible by 1 and itself, right? So our prime numbers are 2, because 1's not a prime number. 2, 3, 5, 7, 11, 13 are just a few of the few. So let's figure out which events are mutually exclusive. Okay, this was supposed to be F and this was supposed to be G. Told you guys, I'm having a day. Okay, so are E and F mutually exclusive? Are all even numbers and all odd numbers mutually exclusive? Yes, there is no number that is both even and odd. What about F and G? All odd numbers and all prime numbers. Are F and G mutually exclusive? No, right? Except for 2. Oh, I gave something away, darn it. Except for 2, all the odd numbers are prime. And what about all even numbers and all prime numbers? Well, those intersect at 2. So these are not mutually exclusive.